Okay, today is November 23rd, 2011. We did lesson 6.2 yesterday. We're going to do question 18 from the homework, and then we'll start lesson 6.3 later. Question 18 states that the length of the base of a rectangular prism is 2 meters greater than the width, and the height of the prism is 15. So we're going to get a rectangular prism. You know what? We'll do it like this. We're going to draw the entire shape. So this is a three-dimensional shape. We'll use our lines to connect this. Okay, so they've told us the height of this object is 15 meters. So our height is 15 meters. It says that the base of the rectangular prism, so I'm going to call the front the base, is 2 meters greater than the width. So our width will be x, and our base will be x plus 2, because our base is 2 meters longer than our width. This will be the base, the width, and the height. Okay? So we have our measurements for the length, width, and height. First question asks us to write an algebraic expression for the volume of the prism in vertex form. They want us to express it in vertex form. So the very first thing I need to do is remember my volume of a rectangular prism. V will be equal to the base times the width times the height. Okay? And we have those three measurements. They want us to represent this in vertex form. So we need it to look like that in terms of the form. Thanks. So we're going to replace our b with x plus 2, our width with just x, and our height with the number 15. We're then going to expand and simplify the question from there. So volume is equal to the base, which is x plus 2, times the width, which is x, times the height, which is 15. Okay. What I'm going to do is, because it's multiplication, technically doesn't matter what order you do this in, as long as you do it right. I'm going to combine my two last terms to start. It'll make it a little easier for me in the long run. What is x times 15? Good. So I now have x plus 2 times 15x. The 15x needs to be distributed to both of the terms inside the bracket. So 15x times x is 15x squared. 15x times 2 is 30x. Now, is equal to the volume. Which form am I roughly in right now? This looks like more like our standard form. The only difference is we're missing a constant on the outside, but we're in our standard form. I guess you could say the constant is 0 in this case. Our a value is 15, our b value is 30, and you could say that our c value is technically plus 0. It's not important to the equation. We're going to focus just on 15x squared plus 30x. Okay? Now what they said is they want us to express it in vertex form. Does anyone remember what we need in order to do that? What's the process called? So we realize that the process we need to do now, we need to complete the square. And if you remember with completing the square, that comes with this formula, creating the perfect square. We are trying to create a perfect square trinomial. That's the entire idea of the process here. So we're going to put this equation on another page and go through this whole process. So our formula was 15x squared plus 30x. Now if you guys recall, in making a perfect square trinomial, we start in our standard form. So we start in standard form. The very first thing I need to do is I need to take out from the first two terms whatever our a term is. So I'm going to divide the first two terms by 15. That will become our common factor. We're going to take that out. So I have 15 on the outside of the brackets, then I have x squared plus 2. For a side calculation, sorry, not just 2, but what? 2x, good. This now becomes our b value for our little creating the perfect square trinomial formula. B is equal, or sorry, it's equal to b divided by 2 squared. So we take the number 2, divide it by 2, and square it. 2 divided by 2 is 1. So we need to add and subtract 1 to the brackets. We'll now get 15 is equal to x squared plus 2x plus 1 minus 1. We need to take the negative value. Oh, I forgot to write the 1 in there. Plus 1 minus 1. We need to take the negative value to the outside of the brackets. And when we do that, we have to multiply by the common term in front. So our next term, or our next line is going to read 15 is equal to x squared plus 2x plus 1. And negative 1 times 15 is negative 15 on the outside. Now that I've done that, I've created a perfect square trinomial. Okay? That's what this is here. The whole point of that was to create a perfect square trinomial. We know we can factor a perfect square trinomial quickly by square rooting the first and the second term. Square root of x squared is x. Square root of 1 is our 1 value. We're going to combine this into one bracket. We'll get x, 1, and whatever the term is in front of our middle in the perfect square trinomial, we have a positive. We bring the positive sign down. Squared minus 15. We've now changed this from standard form to our vertex form. So the vertex form of this equation for the volume of a prism is 15x plus 1 squared minus 15. Question B says that the volume of this prism is actually equal to 2,145 meters cubed. They want us to write an equation to model the situation. Okay? We can actually write two equations to model this situation. Because we know the volume is 2,145 meters cubed, we actually have two forms of this equation we already know. We know the standard form of this equation. That's what we ended up starting in. And we know the vertex form of this equation. That's what we just changed it into. So we're going to write both of them out. Because volume was equal to 15x squared plus 30x, and volume was also equal to our vertex form, which is 15x plus 1 squared minus 15. Since the actual volume is 2,145, we're going to replace that. So I have 2,145 is equal to 15x squared plus 30x. In standard form, we want to set it equal to 0. So I want to move the 2,145 over to the other side of the equation. So we're going to end up with, in standard form, 0 is equal to 15x squared plus 30x plus minus 2,145. In the other equation, it's the same idea. We have 2,145 is equal to 15x plus 1 squared minus 15. When I move in our vertex form, we'll probably want it set equal to 0 again so that we can solve it. I move it over, I get 15x plus 1 squared minus 15 minus 2,145 and negative 15 minus 2,145, negative 2,160. 0 is equal to 15x plus 1 squared minus 2,160. So either of those forms, because they asked us for an equation, would be acceptable. This one's in standard form. This one's in vertex form. Question C. Question C says to solve the equation by factoring. What are the dimensions of the base of the rectangular prism? Remember the original question, they gave us measurements of a rectangular prism. Now I need to factor, and I do have two forms here. In order to factor, which form do I work with? Anyone know? Standard. Our vertex form, we don't factor from there. In fact, in order to factor, we'd have to turn vertex back into standard. Luckily, we already have a standard form. So we're going to factor to solve this question. Very first thing I do in factoring is find the greatest common factor. So 2, 1, 4, 5. Can I take 15 out of it? Yes. Perfect. So we get 0 is equal to 15 x squared plus 2x minus 143. Now, when I go to factor this, the factors of the first term are 1x and 1x. And we know the factors of the other term need to be relatively close together because they have to add up to positive 2x. So we can use that information. Sorry, not that. So we need to find numbers that divide into 143 but are relatively close together. Okay, let's try that. Someone gave us 13 and 11. 13 times 11, 143. Perfect. As a pair of factors, 13 and 11 are 2 apart, so we know right away they're going to work. That's a fast way of going through the factors instead of writing them all out. Use some logic because of the middle number. In order to get positive 2, when we multiply the two columns, we're going to get 13x and 11x. Which one's going to have to be negative? 11. Which means we multiply by the 11. The 11 will have to be the negative number. So we'll have 0 is equal to 15 x and x. So our x is going to be the first term in each of the brackets. And again, because the first terms are the same, we're going to just put positive 13 and negative 11 in one of the brackets. Now, the 15 is going to cancel out. I'm going to skip that step. We normally divide both sides by 15, but we know eventually what we're going to get is 0 is equal to x plus 13, x minus 11. Just as a quick side note in case you were confused. Yeah, you'll need to know this. We're going to split the equation. 0 is equal to x plus 13. 0 is equal to x minus 11. X is negative 13 or x is 11. So I have two answers, negative 13 and 11. Let's go back to our original page. For dimensions, our two options are negative 11 and 13. In terms of meters, could I have a measurement that is negative 11 meters? That one doesn't make sense. So we know that the width is going to be 13. What will our base be in that case? 15. It'll be 13 plus 2 because of our formula. Our base will be 15. So those are the dimensions of the rectangle. Oh, did I mix those? Sorry. So it's 11. Sorry, the 11 was positive and the 13 was negative. So our dimensions are 11 and 13. Thank you.